In this section, I'm going to develop the backend of the application. First, I'm going to use the infrastructure that I created in the past video. I explain more in depth how I create the Terraform code and use it in the cloud provider Amazon Web Services. With that infrastructure, I'm going to connect and use the Docker to start the dev container. Enter to the dev container and install the required software to develop the backend application. First, I'm going to install the Java version that I'm going to use. Install the Maven package, a SpringBoot package to start the SpringBoot application. And then I'm going to explain more in details what architecture I'm going to use. I'm going to show you the different or most popular architectures that we know in the software industries and the best practices. And with that, I'm going to implement or add best practice to our project. I'm going to add the error handling, the JUnit testing for the project. With that, let's see in depth what we are going to see in this part of the video. This is the goal for this section. I'm going to explain more in depth each step to achieve the goals. I'm going to explain for each step what technologies I'm going to use. First, I'm going to use the Terraform code that I write in the past section, and with that infrastructure, I'm going to run two EC2 instances, and in one instance I'm going to run a dev container, and inside this dev container I'm going to use to develop the application. Then I'm going to enter to this dev container and install the tools required to develop the backend. First, I'm going to install the Java version. I can install whatever Java version we want, but in this opportunity I'm going to install Java 21. I'm going to install Maven and SpringBoot CLI. It is an easy process in the dev container. And then I'm going to start the SpringBoot project using the CLI provided for Spring Initializer. I'm going to use the IDE NeoVim to test the project and run the projects. Then I'm going to create the models and controls to show you how the MVC architecture work in this section. Finally, I'm going to talk about the different architectures and the best practice that we will should use in our projects. And with that theory, I'm going to do another hands-on to add this architecture and best practice to the projects. I'm going to show how you should work with the error handler and unit testing in the project. With that, let's start with the project. Okay, after finishing our daily job, we can run the command terraform destroyed -auto approve command to destroy the infrastructure that we created. Now I'm going to run the command terraform apply -auto approve to run again or recreate the infrastructure. I'm going to run this command for the network to create the network of our infrastructure, and then I'm going to run the command in the EC2 instance folder to create the EC2 instances. Let's run first in the Terraform apply in the network folder. Okay, let's check if it started, and I'm going to show you if the infrastructure that we are creating is valid or is created. You can see we created this one infrastructure, hotel VPC manual, and here we can see that the other infrastructure are creating. Let's wait to finish it. Okay, finished the infrastructure for the network. Now let's create or run the command Terraform apply for the EC2 instances. This command will run the code that we wrote in the past video regarding to the creation of our EC2 instances. Let's check here. Let's check here the infrastructure created for the network. You can see here is the ID for the subnet. Here is the public subnet and private subnet. Here is the security group for the database, and here is the security group for the dev container. Now let's check the creation of these EC2 instances. Here I can see the creation of this public IP regarding to the public subnet in that running our public EC2 instance. Let's check in the Amazon console the creation of these EC2 instances. Let's go to the EC2 section to check the EC2 instances running currently in our infrastructure. Here I can see that the EC2 instances are let's wait to finish it to load the data. Here I can see two instances, and here I can see the T3 small. This should be for the dev container, and the other instance is for the database container. Cool. Now we have the infrastructure running, and it should take let me see here, take it 26 seconds plus here take the 2 minutes, and you can see that it takes just 2 minutes and 26 seconds to stay alive with our infrastructure. Okay, it's very fast. Now I'm going to connect to the infrastructure to the EC2 instance. Let's copy the connection to connect the EC2 instance with the SSH client section. Let's copy this command. Let's open a new terminal and navigate to the section or copy your command, and be sure that you modify to point to the SSH key to connect to the instances in your machine. For example, I have this SSH key in my home.ssh folder. Let's connect and wait to this infrastructure is running. Okay, let's check if Docker is running. Docker ps. Okay, running. Now let's to run our first dev container. Here I'm going to run the command docker exec -iterative -detach. I'm going to use the port 80 to to run the front-end application. And here I'm internally in my dev container, I'm going to run the front-end application in the port 2000. And here for the backend, I'm going to use the port 8081, and internally in my dev container, I'm going to use the port 3000. Now I'm going to give a name of the for the container. For example, could be a hotel app, and here I'm going to tell to Docker which image should be run. In this case, I'm going to run the image manual areas / dev container and version 2, and I think it is all to run our first dev container. Okay, let me check what is short flag for -p. Okay, this is an easy error. The execution command is for connect, but here we need to execute the run command to run our first dev container. It is running. Let's wait to finish. It should take 1 minute or 2 minutes, and after finish it, we will have our first dev container. We are going to enter to this dev container and install the tools that we use to developed our backend application in SpringBoot. Let's wait a minute. Okay, finish it. Now let's check if the container is running. Docker ps. Okay, running. Now let's do exec to connect to the container. Let's exec -it. Minus user manual, and the dev container is hotel app container running internally in bash. Okay, I am in the dev container. I can check this with the command uname -a, and you can see the container code is the same that we check. Let's run Tmux. Okay, I run in Tmux started a new Tmux section inside the dev container. Now I'm going to update our dot files in the root, in the folder dot files. I'm going to run git pull command to get all the updated files or recent files that I committed in recently. Now with that, I'm going to install the Java version. For that, I'm going to use the SDK main. Let's open a new pane. Let's close. I opened a new pane just to refresh the memory for the recently updated dot files. Here I'm going to run SDK install Java. I'm going to use the Java 21, and it should be start to install the Java version 21. This we can use with SDK man different version. We can switch in between different Java version with this tool that is very useful. It's the same like a Node version manager if you work with Node. And here you can see that finished the installation for the Java. Let's check the Java version. Okay, here you can see the Java version now is 21. Okay, now let's install the Maven. Is a similar command. Let's check install Maven. Let's Maven. Okay, it's very fast. Now let's install SpringBoot CLI. Okay, I missed the G. Now it is installed. With that tools installed, I'm going to clone the YouTube project. Let's move it to the other folder for the project. I'm going to use this folder in Gallego A, and here you can see I don't have any repository, but I'm going to use the git clone command, and I'm going to use git arrow github.com/u I missed colon and YouTube .git clone. I missed the E. Yes. Okay, we need to add the public key for the repository. I am going to add my public key to access to my GitHub repository, and to add this public key for the repository, first we need to copy the key to the EC2 instance, and in this EC2 instance we need to move or copy this SSH key for the repository to the dev container. Okay, let's do it. First, I'm going to detach from the Tmux session, Ctrl+V+D, and exit from the dev container. Now let's check if we have the folder SSH key. Okay, yes, I have the folder, and here I don't have any other keys. This is the default key for the EC2 instance to authorize the connection from the command line. Okay, let's open a new terminal. Here I am in the local machine, and here I have the SSH key. Let's check. This is the SSH key for my personal repository, and to copy I'm going to use the scp command, and here we have to tell that I'm going to use the key to connect to the EC2 instance in AWS. This is the key for the connection, and here I'm going to specify that I want to copy the local SSH key to the EC2 instance. Let's verify the EC2 instance is this one. Copy and paste, and copy in the folder home EC2 user /.ssh folder. Okay, let's try and wait. It's taking some time. Okay, copy it. Now we have the SSH key in the EC2 instance. Let's close from this machine and go back to the EC2 instance. Now if we verify, we have the SSH key in the EC2 instance. Let's clear. And the next command that I'm going to use is the docker copy, or docker cp to copy the SSH key to the hotel app container. Here in the folder home manual /ssh key. Let's try this command. No such file or directory. Let's to create the directory. Oh, okay, no, I just going to copy in the user folder. Okay. The error here is the name of the container. Okay, I missed the L. Successful copied. Okay, now I'm going to enter to the container again. Clear. Let's check if we have the Tmux session. Yes, we have the Tmux session. Let's to add or attach to the Tmux section with Tmux A to attach. And here we verify if we have the SSH copied. Cool, we have the SSH key. Now I'm going to start the SSH agent and add to the agent the new SSH key. To do that, I'm going to use the eval command to start the SSH agent -start. Okay, started. Now I'm going to add the SSH key for the local repository identity added. Okay, now I'm going to clone this the YouTube repository git clone git raw github.com the user YouTube.git. I think it is the correct command. Perfect. Now we have the YouTube command. Now to enter to the repository for the project, hotel cd hotel, and here we have the infrastructure folder that we previously created to put the infrastructure that we created. Now I'm going to start a new SpringBoot project for the backend. To do that, I'm going to use the spring command in it, but this is a long command. To remember that, I have a small trick. I use alias to save the command that I use frequently, and I'm going to search for the spring command, and here this is the command generally I use to create an SpringBoot project. Okay, let's copy and paste, and let's to double check the command. First, run sprint init -d equal to DevTools to hot reload web to use the SpringFramework web starter, lombok, Data-jpa, h2 validation. I think I'm going to install or use the mysql starter -build. It should be Gradle Maven. The group ID is com.co.manual. The Java version 21 correct. The name of the project is hotel, and the type project is Maven project. It's a Maven project, and the name of the folder is the Backend hotel. Cool. I think it's okay. Let's run using the API for start.spring.io project extracted here. Okay, and let's move to the backend hotel folder. Here we have all the files and folder required to run the SpringBoot application that we created. I'm going to check if all is in order to run. To do that, I'm going to run the SpringBoot run command. This command will connect to the Maven repository, download the dependencies declared in the pom.xml, and run the application. Cool. Here we now see that we have a Tomcat embedded server in the port 8080. I'm going to change this port 8080 to 300 because remember when I started the container, I mapped the port 3000 to the port 8081. I will use this for the backend. Okay, let's stop the server and let's check the pom. This is the pom.xml. Now I'm going to open a Java file, and this will be a file, the GDTL, the language server for Java, because that Java file is mapped to the GDTL language servers for Java. Here you can see in the button in the left, the service is ready, and we are ready to develop the application. Okay, first I'm going to create a models for reservation .java. Here I'm going to define a class with an integer ID. This will be our ID from the persistence for the persistent package. We need to add the annotation entity to tell or to use the Data-jpa. We have the ID, and we are going to define a string date in, a string date out of the guest, and private string cost. Okay, and here we have an ID. I'm going to change for the long. Okay, and I need to define how this ID will be generated. To do that, I'm going to use the generated valued annotation. Generated valued, okay. And here the strategy for this, and the strategy to use is the identity strategy. Okay, let's save, and this warning is showing for the language server and indicate that we need to use the getter and setter for these private attributes. To do that, I'm going to use lombok. Lombok is a library that facilitates this task. To do that, I'm going to use the data annotation from lombok, and you can see the warning disappear. Correct, I have the reservation. Now we need a guest to do a relationship between the guest and the reservation. And to do that, I need to declare another entity, guest.java. And in this entity, I'm going to declare an ID, integer ID. And in this ID, I'm going to define this is an ID, and this have the generated valued attribute and the strategy equal to identity. And I need to mark this class like an entity. Okay, perfect. And I'm going to define the name of the guest. Cool. This error, to solve this error, the same, I'm going to define the data annotation to say lombok generate the getter and setter for this class. And I'm going to define the list of the reservation from Java util. I'm going to use the interface from Java util and define the reservation list. And here we have the reservation. Now I'm going to tell that this guest entity have many reservations for this guest. To do that, I need the one-to-many annotation, and here we have to define the cascade attribute, and this I'm going to use all for merge, and for delete I'm going to define the orphan removal. This attribute define that when we remove one guest, the children will be removed. Okay, and here we have to define orphan value to true. Perfect. Let's say now we have the models guest and reservation. Now I'm going to define the controllers for guest controller .java. In this class, I'm going to define the REST controller. We need to add the REST controller annotation and the request mapping annotation. For the moment, I'm going to map to the /root. Here we need to define the get mapping to get all the guests, public list of the guest. Okay, perfect. And name the method get all and returned. Here we going to return the repository. To do that, we need to define the repository for the guest. I'm going to create a folder repository. Yes, repositories guest repository. Java. Okay, here we need to define an interface. Okay, some problem with the snippet interface. Okay, perfect. And in this guest repository, we need to extend the JPA repository to define the create, update, and delete methods for the guest, and the ID it is an integer. Okay, let's double check the identifier. Okay, I call it the ground one because it is not the guest. It is guest from models. Okay, and let's do double check it is integer. Correct, it is integer. Let's double check the name. To avoid confusions, I'm going to rename the guest to the guest controller. Let's change, and I'm going to use the language servers to rename. Go to change name. Okay, change to guest controller. Okay, perfect, change it, and here change it, correct. Here I'm going to declare the repository, guest repository interface to guest repository, and here I need to define, this is a repository stereotype, and here we define it. Here I'm going to use the auto-wired annotation for the moment, but the best practice is create or inject the Vim in the constructor. But for the moment, I'm going to let this way, but I'm going to change in a future. And here I'm going to return change guest repository that find all. Okay, save, and define the post mapping, and here I'm going to create the method public, return a guest, and create method, and here I'm going to receive in the request body a guest object, and here I'm going to return the guest repository that save a guest. I forgot to define the variable. Here I need okay, now we have our first controller defined. Let's to test this one. To test this, I'm going to use the Kulala package. I'm going to show you in a moment. Here in the test, I'm going to define or create the controllers folder, and here I'm going to define the guest controller.http file. Here I'm going to define our first get request to http :// host :/. Okay, save. And I'm going to use Kulala. Kulala is a package installed in NeoVim with Lazy. It's installed in the Dev-container, and with Kulala we can have these HTTP or REST files, and we can document the request of the project, and this allow to the other team members to run the same request. It is very useful in the daily job. Here I'm going to open a new pane, and here in the new pane I'm going to run this application. But first we need to configure what database I'm going to use. To do that, I'm going to open the application.properties here, but I would like to use the YAML specification application.yaml. Okay, and here in the YAML I'm going to define the server. In the server I'm going to define the port 3000. Okay, this is the port number that the application or the Tomcat will listen. And here I need to define the connection to the database. At the moment I'm going to use the H2 database. This is a in-memory database. To do that, I'm going to define the Spring attribute and define the data source and the URL. It is gdbc h2 memory, and the database called hotel h2. Perfect. The username is the default is SA. The password is a blank password, and here I'm going to define the JUnit attributes. First I want to show the SQL, just to print the SQL. What another thing? Okay, let it be. Let's save. Okay, I need to define the Hibernate attribute just to define the type of DDL to create. This define or tell to the Hibernate when we start the application, we need to create the database. Okay, let's save and close and check if it's working fine. Let's run the project and check if it's running correct. Okay, starting, and here we are waiting to the server starter, and I'm going to open a new Windows to run the REST request, for example, but first check. Here we have the excuses. I need to go to the end. Okay, here the Tomcat started on port 300. Okay, I'm going to open a new Windows in the top of the Windows and go to the test folder, and here open the request for guest. Let's run using Kulala to run this request in the port 3000. Let's run and let's check what is going on. Here the request is 200. This means that the server is running and the response is correct. Now I'm going to create one guest. For example, let's create the post request. Let's copy this, and here I'm going to tell the content type to application JSON. Okay, and the object that I'm going to create is the name Manuel guest, and the reservation is an array of reservation objects. For example, here is the date in, for example, 6/10/2025, comma, and paste. Let's change to date out, and here is the for example 9, and the cost is for example 700. Okay, let's run this creation for the guest, and here we have a bad request error. Let's check what is going on. Parse exception, unexpected character. Let's double check. Here appeared that we need a comma here. Let's rerun. Okay, perfect, created, and let's check the request. And here let's test for the two or the second guest, and here search for all guests. Here we have two guests created, correct, and the application is running good, and we created our first MVC application. Now I'm going to talk about the best practice that we need to implement in this application, because I show how you can use the Spring MVC to create a simple REST API to create and search for or find all the guests. But here in this point I'm going to talk more in depth about the architecture that we are using and the best practice or recommendation to develop the application.